Okay, this video is going to explain where light comes from on an emission spectra. So I'm going to show how that works. So the first thing you need to know is a little bit about the electromagnetic spectrum. Now, the electromagnetic spectrum is composed of several waves like radio waves, microwaves, infrared, ultraviolet, X-rays, gamma, but there's a small part of the electromagnetic spectrum that humans can actually see, and that's called the visible spectrum or visible light. Okay, now you probably know what that is. You've probably heard of it. But basically, there's like something that can help you remember. It's like Roy G. Biv. Okay, that's supposed to be an O there. So it goes like red, orange, yellow, green, blue, indigo, violet. And that will help you, if you can remember Roy G. Biv, that will help you remember the name of the order, I guess, that the visible light spectrum goes in, just like a rainbow. Okay, so anyway, but the one thing that you need to know is that, like, which light, okay, has the most energy or the least energy. So this light is composed of little pieces of energy called photons. Okay, that's what makes up the light. Now, photons have specific energy. Like a red photon has so much energy versus like a violet colored photon. All right. So, which type of photon has the most energy if we compared like red or violet? All right. Well, the violet light is up here, and you can see that the energy increases. So violet has the most energy where red has the least. So if you can remember Roy G. Biv, it goes in order from lowest energy to highest energy. Red the lowest, violet the most, green kind of in the middle. Okay? So that's kind of something that you should know there. Now we're going to learn like where these photons come from. All right, so let's say we had a hydrogen atom. All right, so here's a hydrogen atom and it has one electron in the 1s, let's say. All right, now you can do something to this electron to make it jump from a lower energy to a higher energy. So let's say we ran some electricity through it or did like when we did the flame test. Okay, but we excite this electron and we make it jump. So the bottom part is called the ground state. All right, we're going to make it jump from the ground state to an excited state. So let's say we make it go from the first energy level and it jumps up. So it goes up and it goes up somewhere in the third. It doesn't matter, 3s, 3p. Okay, so it's somewhere up there in the third. So now it's in what's called the excited state. All right, I'm going to get rid of it here because it's no longer down here in the first. Okay, so now it's in the excited state. Well, electrons, and just like everything in nature, will always go from high energy to low energy. So this electron is going to fall back down to a lower energy level. So it's going to go back down. And let's say it falls from the third to the second. All right. Well, there have been some studies that have shown that the fall in a hydrogen atom from a third to the second energy level, so if it goes down to this one, let's say, that corresponds to a photon of red light. And I'm hoping we'll have time to look at this in class, but with hydrogen, you can actually see this red light when an electron is falling from a higher energy level to a lower one. All right. So that's where it comes from. Okay. So basically, where does this light come from? Okay. It's when an electron falls from a higher energy level to a lower energy level. So when it's falling down, it's said to emit a photon. And sometimes the photons are just the right amount of energy that they correspond to this visible light. Okay? And so supposedly in hydrogen, you can have one fall from like the sixth energy level to the second. See how that's a much bigger change in energy from the sixth to the second? and that emits a photon with more energy, and that emits like a violet light colored photon. All right. And then if it was just a little bit less energy, like 5 to 2, then it emits like a blue one where it looks more blue because it's lower in energy. The bigger the jump in energy levels, the higher the energy of light. Sometimes electrons fall such a small distance, like let's say one fell from the 6th to the 5th. See how little bit of energy that is? That's such a small amount of energy that it doesn't correspond to the visible spectrum. Humans couldn't see that, but that could be something like maybe infrared radiation where we can't see it. Sometimes electrons fall from such a large range of energy, like maybe one could be way up here in like the, let's just say like the 7th energy level, and it could fall all the way down to like let's say the first isn't shown here, n equals 1, that means the first energy level. Well, that drop of energy is so, change in energy is so much that the photon is outside the visible spectrum. It could be somewhere up here in the ultraviolet light that humans can't see. But when a photon falls just the right, or an electron falls just the right amount of energy, the photon emitted corresponds to a color on the visible spectrum that humans can see. Okay, so the main thing is you got to know like how is visible light, like what causes that. So visible light is caused basically by this. So it's caused when an excited electron drops from a higher energy level to a lower energy level. It has to get rid of some of its energy to go down in energy. It has to get rid of some. So when it drops from a higher energy level to a lower energy, okay, it emits a photon. Okay, and a photon is energy that sometimes people can see. Okay, so a photon is an amount of energy that people can see. So when it emits just the right amount of photon, okay, we can see it. So it emits a photon of light energy. All right. So the other thing you need to know is what type of photons have more energy than others, I guess, in terms of the visible spectrum. And so, for instance, a blue photon would have more energy than a red photon. Okay? So you need to know that the order of the electromagnetic spectrum from red to violet goes from lower energy to higher energy. Okay? So that's what you basically need to know for this unit. It's pretty simplified. That's it.